This video is just a compilation of all the all the 5 sections related to the sample question paper 2024-2025. We go about it section by section. I also discuss it as to where each of these questions are asked from your textbooks and how you could potentially solve each and every one of them. I did find section D and E slightly more difficult than the remaining sections, so more power to you guys. You're doing a phenomenal job of preparing for your board exams and all the other exams that you're going to be writing. So good luck. I'm proud of you, and definitely let me know if you have a question or if you have a suggestion. I'm more than happy to listen to them. Okay, here goes. So one thing I was always told when I told somebody I was preparing for my board exams was that, oh, you should totally go and look at the old question papers. And that was all fun, but it brought on a lot of exam stress that I had been holding in, and that was not great. So I decided to start a video series where we discuss previous year's papers, and this is the first video for that series, and we're going to be discussing the sample question paper for this year, and we're specifically focusing on the section A questions. First of all, before I start, basically you're going to have the questions over here. The solutions are right here. This is the marking scheme given to you by CBSE. And what I've done is I have taken the particular parts of your textbook that have the answer to these questions. So this is also going to help you know where to look for when you're where this answer came from, basically, because most places you can see people give you the reason, people give you everything like that, but no one actually points out to where it is in your textbook. And I think that is a really important thing to know. So we're going to start with section A, and we're going to just do that for this video. So it consists of 16 multiple choice questions, and each one carries 1 mark, and there is no internal choice. Remember, there is no internal choice, and you might want to just think about the answer a little extra when you're answering these questions, just because the way the options are written can sometimes be misleading. So the first question is a monolysis of ethyl chloride followed by the reaction of the amine so formed with 1 mole of methyl chloride gives an amine that. So basically, let's write this reaction. This reaction is already mentioned over here. It's the monolysis reaction of chloroethane or ethyl chloride, and it forms CH3, CH2, NH2, and then this on reaction with another mole of methyl chloride, it gives us a secondary amine. So the question over here is about a particular reaction called the Hinsberg reaction. Or the Hinsberg reagent. So Hinsberg reagent is a benzyl sulfonyl chloride. When it reacts with a primary, secondary, and tertiary amine, or it actually doesn't react with the tertiary amine, but basically when it reacts with the primary amine, it forms a product which is soluble in alkali, whereas for a secondary amine, it does not contain any hydrogen atom, so this is not acidic, so this is insoluble in alkali. And tertiary amines do not react with the benzene sulfonyl chloride. Okay, all of this is from the chapter amines. Okay, now and specifically it's the reaction of amines, and the monolysis, obviously obviously synthesis of amines. So the first one is react with Hinsberg to form the soluble alkali, salt which is soluble. It's true for primary amines, but the product that we have gotten is a secondary amine. The second option, it reacts with, we're going to come back to that in just a second. The third option is obviously the right one, as it is given in your marking sheet, but basically it's because it's insoluble in alkali, and that's what's mentioned over here. And the last one is does not react with a Hinsberg reagent. That's a tertiary amine. Tertiary amines do not react with the Hinsberg reagent. So but the product that we've gotten is a secondary amine, so that's not the answer as well. So the answer is option 3. Now, on reaction with nitrous acid, it produces, on reaction with nitrous acid, it produces nitrogen. That is true only for the primary aliphatic amines, but the product that we've gotten is a secondary amine, but for primary amines, you get the nitrogen gas, and because of that, the second option is also incorrect. Okay, now the next question is, which of the following has the highest dipole? Now, based on these options, it's quite obvious which chapter this is from. This is from the chapter haloalkanes and haloarenes, right? Organic chemistry is one of my is my favorite. So this is basically from the nature of the CX bond. Let's just go over it in brief. Basically, the carbon and halogen atom, this bond that's present has a dipole moment because of the difference in electronegativity. Carbon is less electronegative than compared to our halogen atom. Now, because of that, you have a electronegativity and you have a dipole moment happening because of that, because of the difference in electronegativities. Now, from this table, it's quite obvious what the answer is. It is CH3 Cl with a dipole moment of 1.860. Now, you might be thinking, if fluorine is more electronegative, so obviously it has to have the highest dipole, but that's not the case because the size of the fluorine atom is smaller than that of the chlorine atom. Now, because of this difference in the size between fluorine and chlorine, you have a difference in the dipole moment. Dipole moment is basically a product of the charge and the bond length. So if you notice, the bond length for CH3Cl is larger, right, compared to that of CH3F. And because of that, and because of the higher electronegativity, or relatively high electronegativity of chlorine compared to the ones below it, you have the higher dipole moment for CH3Cl. Okay, we're comparing bond length to the atomic size to chlorine and electronegativity of chlorine and the different elements in the group. So the answer to this question is going to be CH3Cl, and I hope that makes sense. Let me know if you have any difficulty. Okay, now the next question given to us is a match the following. Now, from the question and the options that are given, which chapter do you think this is from? If you said D and F block elements, you were right. So this question is basically related to the chapter D and F block elements. Now, the option... and the thing is, I found the answer to this question in the electronic configuration and radii of lanthanoids and actinoids. So it's all given here. So the first question is, actinoid having the configuration read on 5F761-7s2, that is cerium, with the curium with the atomic number of 96. Now this is CM, and it's a direct it's a direct question almost. Lanthanoid having 4F14 electronic configuration in the +3 oxidation state. The answer to this is lutetium. If you see it here, you have the 4F in the +3 Ln +3 state. It has just 4F14. So this is just this, and then the lanthanoid showing +4 oxidation state is obviously going to be cerium, and you have the lanthanoids with the different oxidation states given in this table, and this is actually given in the beginning of lanthanoids and actinoids. So the answer to this question is option A. Now the next one is, we need to study the graph that's given. It's a very fancy graph actually. And this is talking about bromoalkanes. So this is obviously from the chapter haloalkanes and haloarenes. Now, basically what we've been given is these 4 options, right? We have bromomethane, bromobutane, 2 bromobutane, 1 bromobutane, and 2 bromo 3-methyl propane. Now, basically all of these are actually given to you in your textbook. So these options are actually given, right? This is the thing that's given in your textbook. That's what I copied and pasted over here. So first of all, haloalkanes and haloarenes have a higher boiling point because of the intermolecular forces of attraction. They have a dipole-dipole moment and van der Waals forces, and the attraction becomes stronger when the molecules get bigger in size. So obviously the one with the least amount of or the smallest boiling point is obviously going to be bromomethane. So this is going to be bromomethane. So I'm just going to write or I should have written CH3Br. Anyways, CH3Br. So that's bromomethane. So that's going to have the lowest. And the next one we need to know, the next thing we need to remember is, as you have when there is an increase in branching, what happens is the boiling point becomes lower. when there is more branching. Essentially, what I'm trying to say is that as more is the branching, less is the boiling point. So the next one is going to be 346, and the values are actually given here. So 346, which is 2-bromo, 2-methyl propane. Okay, and then you have this CH3, CH2, CH, CH3, which is 2-bromobutane. So it's in the second position, 2-bromobutane, and then you have 1-bromobutane. So 1-bromobutane is going to have the highest boiling point, and then the low after that it's going to be 2-bromobutane, and then it's the 2-bromo, 2-methyl propane, and then you have bromomethane. So the answer to this question is going to be option number D, with bromomethane. Then you have 2-bromo, 2-methyl propane, then 2-bromobutane, and 1-bromobutane. That's the highest. So the question for visually challenged learners is just which haloalkane has the highest boiling point, and the highest boiling point belongs to 1-bromobutane, which is option D. Okay, now the next question over here is question number 5. The initial concentration of R in the reaction RP is 4.62 into 10 to the power minus 2 moles per liter. What is the half-life for the reaction K and they've given us the value of K. Now basically this is from the chapter Chemical Kinetics. Now the thing you need to know, I keep making this mistake. The thing you need to know is the value of first of all, okay, you basically need to know this table. That's what I was trying to say. So basically, if you notice, the value of K over here is in moles per liter per second, and that is for a zero order reaction. So this reaction is a zero order reaction. For a zero order reaction, the value of T half, which is what they're asking us, is going to be equal to R naught by 2K. That is the initial concentration by 2K. So what we're going to do is T half is equal to initial concentration, so 4.62 into 10 to the power 2 moles per liter divided by 2 into 2.31 into 10 to the power minus 2. Oh, I'm sorry, there's a minus 2 here. And we know the units over here, moles per liter per second. Now, obviously, moles per liter gets cancelled. Second goes to the numerator. So, this is the right equation. Always double check your units. Your units are a very good indicator of if you are in the right, or if you've used the right formula, stuff like that. Definitely use the units. I wish someone told me this when I was in grade 12. So T half, so you basically can cancel to 10 to the power minus 2, 10 to the power minus 2. Then 2.31 is basically, or 4.62 is 2 times 2.31, so 2. And then so 2 and 2 gets cancelled, so you're just left with 1 second. So the answer to this question is option number C, which is 1 second. And so this is related to the chapter Chemical Kinetics, and that's what is given in your in the like in the solutions part of the marking scheme. The sixth question. When CH6H5COOCOCH3 is treated with H2O, the product obtained is. First of all, if you've noticed the options and even like the question given to you, it's basically it's an anhydride, right? It's an acid anhydride. Now, this is from the chapter aldehydes, ketones, and carboxylic acids. So this is actually a preparation method of acids from acyl halides and anhydrides. Oh my goodness. Okay, acyl halides and anhydrides. So benzoic ethanoic anhydride. Actually, this was a acid anhydride, but basically benzoic ethanoic anhydride, when it undergoes a reaction with water, it gives us benzoic acid and ethanoic acid. So this reaction is actually given in your textbook. So just mark that off, right? The next question, the seventh one. Formulation of cobalt 2 chloride ammonia complexes, and actually this is from the chapter, if you notice, cobalt 2, that is from the chapter coordination compounds. or coordinate chemistry. I found this chapter so difficult, and I don't know why. Even in my master's, I found this chapter difficult, so I don't know why. So basically, it's just the table that's been given to you in your textbook. So you have yellow, 1:3. So that's Y is 1:3, and X is going to be, it's the green one. So that's COCH2 NH3 4 plus Cl minus. So we're, oh no, oh no. Um, I'm just gonna say that. Okay, so the answer to this question is going to be obviously option number B. And this is based on the table given to you in your textbooks. Okay, the next question. Which of the following contains only beta glucose as its monosaccharide unit? Now, this is from the chapter Biomolecules. And basically, cellulose is the one which is only composed of beta glucose units. The remaining are not, and I just chose to include the cellulose. Okay, the next one is question number 9. Which of the I should just, okay, yeah, it also gives you here starch contains only alpha glucose, sucrose contains alpha D glucose, and beta D fructose. Glucose and maltose contains alpha D glucose, and cellulose is the only polymer which has beta D glucoside. Next question, question number 9. Which of the following sets correctly represents the increase in paramagnetic property of the ions? Now, this is from the chapter D and F block elements, if you notice. So this is basically related to the chapter D and F block, and this is related to the magnetic moments. And this is actually, again, given in your textbook. So we're talking specifically about 4 of them, which is the ones that we care about for this question is titanium, Ti3 plus, the titanium ion, and then you have Fe2 plus, Cr3 plus, and you have Mn2 plus, right? Now we need to figure out the order of the paramagnetic property. Now, basically, if you notice, there is a difference in the number of unpaired electrons between all of these. So the number of unpaired electrons for Ti3 plus is 1. Number of unpaired electrons for Fe2 plus is 4. And then you have 3 electrons for Cr3 plus and 5 electrons for Mn2 plus. More is the number of unpaired electrons, more is, or that is what determines the paramagnetic property, right? So the paramagnetism depends on the number of unpaired electrons. So Ti3 plus has the lowest. So out of all of these options, A, B, and D have the Ti3 plus is the lowest. Then you have Cr3 plus, which is option number D, and then you have Fe and then Mn. So more is the number of unpaired electrons, more is the paramagnetic property going to be. Based on that, we just answer this question. Okay. The next question. The first order reaction is found to have a rate constant K equals to 5.5 into 10 to the power minus 1 minus 14 seconds inverse. So the time taken to completion of the reaction, actually it never undergoes completion. Now this is because the rate of the reaction is directly proportional to the concentration. Because it is directly proportional to the concentration, as you have a decrease in the concentration of reactant, the rate of the reaction will also start to slow down. Okay, so no matter what, when you start slowing down, so what happens is there comes a point where the amount of reactant is so small that the rate is also going to be significantly small. So because of this, the reaction is never going to undergo completion. So we don't have to math this, we just need to know the logic for this question. And this is obviously from the chapter Chemical Kinetics. Next question. A student was preparing aniline in the lab. She took a compound X and reduced it in the presence of nickel as a catalyst. What would be the compound X? Basically, what we're talking about is a reduction reaction, right? Reduction reaction to form aniline. So what will undergo reduction to give us aniline? If you said nitrobenzene, you are right. Basically, this reaction is actually given to you in your textbook. Here you have NO2 and it undergoes It undergoes reduction in the presence of hydrogen and palladium and ethanol, right? But basically, it's the same concept. You have reduction taking place. You have nickel as a catalyst. So it's a different catalyst, but basically, you have nitrobenzene undergoing this reduction reaction. So the answer to this question is going to be nitrobenzene. Which of the following compounds give us a oxime? And this is from the chapter amines. It's actually the preparation of amines. Okay, reduction of nitro compounds. The next question over here we have is, which of the following compounds gives an oxime with hydroxyl amine? So oximes are formed when aldehydes or ketones react with OH, or they don't react just with OH, but this is that react with hydroxylamine to give us oxide. And this is true for aldehydes and ketones. Out of the options that are given to us, CH3COCH3 is a ketone, right? You have CH3COOH, ethanoic acid, which is an acid. You have CH3COOC. Okay, this I will write it out for you. CH3COO. I'm pretty sure I've written it. No. Hang on. No. Sorry. Sorry. COCH3. So this is an acetic anhydride, and this is an acyl chloride. So out of all of these options, only option A is a ketone which undergoes a reaction with hydroxylamine to form oxide. And this is under the first, it's actually one of the first set of reactions that you learn in the chemical reactions of aldehydes, ketones, and carboxylic acids. I think it's a nucleophilic substitution, addition reactions. Okay, so that is the answer. Your answer to this question is going to be option A. The next question you have over here is an assertion and a reasoning question. So out of, for assertion and reasoning questions, you have both A and R are true. R is the correct explanation of A. Both A and R are true, but R is not the correct explanation of A. A is true, R is false. A is false, R is true. Honestly, these sort of questions used to confuse me in the past. Sometimes it does even now, but it's okay. So the question over here is, they've given us a complex. It has a magnetic moment of 2 unpaired electrons, while this complex has a paramagnetic moment of 4 unpaired electrons. And the reason is because of the inner orbital complex, and the other one is an outer orbital complex. So this is from the chapter coordinate chemistry. So this is from the topic magnetic properties of coordinate compounds, and this is actually an example which is discussed over here. So according to this, you have you have a species containing so you have it here. So it gives you the whole thing, right? And the reason is this is apparent anomaly explained by valence bond theory, and this is under the concept of valence bond theory. So based on this, both A and R are true, and R is the correct explanation of A. And if you want me to clarify or explain a question in detail, definitely let me know. I will be more than happy to do so. This is just me trying to, speed up and make sure your time is also saved. So we've next been given question number 14. It's also an assertion and reasoning question. For strong electrolytes, there is a slow increase in molar conductivity with the dilution and can be represented by this particular equation. The value of A, the constant A for NaCl, CaCl2, MgSO4 in a given solvent at a given temperature is different. So first of all, based on looking at the word electrolytes and conductivity, we can assume safely that this is from the chapter electrochemistry. Now this particular sentence is given word to word in your textbook. You'll be surprised at the number of things I found in the textbooks. I wish I knew, but you know what? When you're stressed about learning maths, physics, and chemistry at the same time, I feel like it becomes a little more complicated. As an adult, I quite enjoy solving these papers. So we've been given the exact same sentence. However, if you notice, the equation is incorrect. So obviously A is going to be false. However, the value of the constant A for NaCl, sodium chloride, CaCl2, MgSO4, all of that is given is also this, again, the same sentence is mentioned over here. So the value is dependent on, for a specific temperature, it actually is dependent on the nature of the electrolyte or the type of the electrolyte, and because of that the values are going to be different. So for this we would pick A is obviously false, and we're also going to say but R is true. This because we're not going to talk about, you could say R is not, yeah, R is true, A is false. We know that for a fact. Okay. Now the next question over here is question number 15. Glucose does not form a hydrogen sulfide addition product with NaHSO3. Reason it exists in a 6-membered cyclic structure called pyranose structure. Now my initial instinct when I saw this question was that obviously A is right and R is also right, and R is the right explanation for A. However, that is not the case. So this is based on the cyclic structure of glucose. So in the cyclic structure, you have, despite aldehyde group, glucose does not give a Schiff's test. It does not, and it does not form the hydrogen sulfide addition product with NaHSO3. So obviously it does not do that. But you need to, for the reason itself, it needs to say that it does not have a free aldehyde group, right? The free aldehyde group explains the fact that it does not undergo this reaction. Okay, it existing as a 6-membered chain is true. However, that is not, it is an implied reason, right? So you need to have it mentioned clearly, and because of that option, both A and R are true, but R is not the correct explanation of A. Now if it had told that glucose exists in a 6-membered cyclic structure called pyranose structure, which does not have a free CH or an aldehyde group, then you would have been able to tick option A. You have to do option B because it is not the right explanation, because it does not mention the presence or the absence of a free aldehydic group. Okay, so that's from the chapter Biomolecules, and this is the last question for this video. You have the half-life for a zero-order reaction is independent of the initial concentration of the reactant. For a zero-order reaction, rate is equal to K. I keep doing this. All right. For a zero-order reaction, we know that it is independent to the initial concentration. That is definitely not the case. It's right here. So that's A is obviously false. For a zero-order reaction, rate is equal to K. That is true, and because of that, A is false, but R is true. So option D is the right answer. So let's start with this. So this section contains 5 questions with an internal choice in 1 question. The following questions are very short answer type, and they carry 2 marks each. Now, the first question. Nitrogen gas is soluble in water. At temperature 293 Kelvin, the value of KH is 76.48 kilobar. How the solubility of nitrogen vary at a temperature above 293 Kelvin if the value of KH rises to 88.8 kilobar. Now, based on this, first of all, we need to find out how will the solubility of the nitrogen change when you change the temperature. Okay, that's what we're trying to figure out. Now, the thing we've been given is the value of KH. That automatically implies that this question is related to Henry's law, and this is under the chapter Solutions. So the value of KH has been given to us in 2 cases. It is 76.48 kilobar when the temperature is 293 Kelvin. Okay, and the value of KH has also been given as 88.8 kilobar at higher than 293 Kelvin. Now, the value of KH is the Henry's law constant, right? So, according to the Henry's law constant, different gases have different KH values at the same temperature. And also, so that means it's dependent on the nature of the gas. Also, the value of KH depends upon the temperature itself. Now, when you have a higher value of KH at a given pressure, the solubility, the lower is the solubility of the gas in the liquid. So this implies that the value of KH when it increases, the solubility is decreasing. So the solubility of nitrogen over here will decrease when you are increasing the temperature. So that's what is given in your solution, in the solution over here. So they've mentioned 2 important points, and each of them carry half a mark each. Right. So solubility of a gas is inversely proportional to the value of Henry's law constant, or Henry's constant. On increasing the temperature, nitrogen becomes less soluble because the value of KH goes up. So that's all. So as long as you have both these points included, you're good to go. The second question over here is chloroform boiling point 61.2 degrees Celsius and acetone boiling point 56 degrees Celsius are mixed to form a azeotrope, or an azeotrope. The mole fraction of acetone in this mixture is 0.339. Predict the boiling point of the azeotrope formed, and we have to defend our answer. Now, from the word azeotrope, this is also from the chapter solutions, and this is specifically from the topic of non-ideal solutions. So under non-ideal solutions, we had learnt about 2 deviations from Raoult's law. You have a positive deviation and a negative deviation. Chloroform and acetone, this particular mixture, undergoes a negative deviation from Raoult's law. This is because the AB interactions, that is the interaction between chloroform and acetone, is much stronger because of the formation of a hydrogen bond, or intermolecular hydrogen bond, which is formed. Okay, so this in turn, what will happen is, leads to a negative deviation from the Raoult's law. Okay. Now, we also learned about azeotropes under this. So the solutions that show a large negative deviation from Raoult's law will form maximum boiling azeotropes at a specific composition. Because it is forming the maximum boiling azeotrope, right? This means, and because of the negative deviation from the Raoult's law, the boiling point will be 64.5. because of the strong interaction. So because the interactions are very strong, they are forming a negative deviation from Raoult's law. They are forming a maximum boiling azeotrope. So their boiling point will be higher than the boiling point of the individual components. Okay, so that's why you have the answer over here. You will have to include the fact that you think the answer is 64.5. And why do you think that? It's because of the negative deviation from Raoult's law. So you need to include that point, and you also need to include that it's forming a maximum boiling azeotrope, and so the boiling point which is obtained will have the higher will be higher than that of the individual component. So you need to include all these points. So that's 17, question number 17. The question has an internal choice. So the second part of the question, a soda bottle will go flat or lose its fizz faster in Srinagar than in Delhi. Is this statement correct? Why or why not? So again, this question is based on the chapter solutions, right? So this is, okay. So this is basically under the concept of Henry's law. At higher altitudes, the partial pressure of oxygen is less, and because of that, you have people have to take additional. Climbers actually have to have additional oxygen tanks and stuff. This will help them minimize the symptoms called as anoxia. So what we care about over here is that at higher altitudes, partial pressure is less than that of oxygen at the ground level. So this automatically implies at higher altitudes, even for carbon dioxide, the partial pressure will be less than that in the ground level, and this will lead to a decrease in concentration. And because of this decrease in concentration, you have it losing fizz faster at higher altitudes. So that's what it says over here. At higher altitudes, the atmospheric pressure is lower. Solubility is directly proportional to partial pressure over the solution. So carbon dioxide will be dissolved lesser in Srinagar, making the soda go flat faster. So this is related to the concept of Henry's law. How does sugar help in increasing the shelf life of the product? Now this is related to the concept of osmosis. So this actually has been given in your textbook under the concept of osmosis. So the preservation of meat by salting and of fruits by adding sugar protects against bacterial action. This is through the process of osmosis, and the bacterium on the salted meat or candied fruit loses water, shrivels, and dies. And that's exactly word to word is what has been written over here in the solutions or the marking scheme given in your given in the CBSE website. So basically question 17 was related to the chapter solutions. Question number 18. Write the IUPAC name of the following complex. Oh, KrCr H2O twice, Cr2O4, C2O4 H2O. Okay, I shouldn't even have bothered reading it. What we're going to do is, so this is obviously from the chapter Coordination Chemistry. And let's first write down our question. So K potassium Cr H2O twice, right? And then you have C2O4 twice. I guess I can scroll to the side. And then you have H2O. Right, so this is the question. So first of all, the cation is named first, right? So that is going to be potassium. The next one are going to be our ligands. So the ligands over here, you have water, which is going to be called aqua. And then you have C2O4, which is the oxalato. Okay, and you have two of them, so we are going to have to include the word di. Right. Now, you have oxalato for this, and this is going to be in the alphabetical order because water is aqua. This obviously is going to come first. Now, the central metal, which is chromium, it has to end with 8, so it is going to be chromate. Right. Now, we need to have the oxidation state of the chromate or of our central atom. So that is going to be 1 plus x plus 2 into 0 plus 2 into minus 2, because aqua or water is a neutral one and oxalate is a negative negative ligand. Oh my god, negative ligand. So it's going to be, so its total is going to be equal to 0. So x plus 1 minus 4 equals 0. X is going to be equal to 3. So this is the oxidation state of our chromate. Right. So the name of this particular complex is going to be potassium. P-O-T-T. I apologize for spelling potassium so incorrectly over here. So you have potassium, and then you have your ligands. So diaqua, dioxalato, chromate, 3 hydrate. That is the H2O over here. So that's the name. And if you and this is obviously from the chapter Coordinate Chemistry or Coordination Compounds, and it's under the naming of mononuclear coordination compounds. So basically we started with the potassium, which is the cation, and then we moved on to the anion. Under the anion you have two ligands, diaqua, dioxalato, and then chromate. And then we calculated the oxidation state of the chromate, and then we were able to find out the name or write the name. So the next question, name the metal present in the complex compound of hemoglobin and vitamin B12. So this is under important compounds related to, or important importance and applications of coordination compounds. One of them is about the importance of the coordination compounds in biological systems. So you have hemoglobin, which is a compound of iron. So iron is going to be the metal present. So this is Fe. And for B12, cyanocobalamin, the coordination compound of cobalt. So CO. CO. Okay. The next question. Okay, this question has been one of the very difficult ones to answer, and I have not been able to find a valid reason for me to be okay with this. The only thing, okay, let's first of all, question number 19. Observe the following cell and answer the questions below. So we've been given this cell and we need to answer these questions, right? Now, the first question is represent the cell shown in the figure. So for the representation of a particular cell, we need to figure out what the what the anode, cathode, and the salt bridge are. Okay, now my issue with this is that we've not been given the direction of the current. And that's fine. We can try and figure it out. However, when you look at the answer over here, it implies that this particular... Okay, let's... So usually we will have our anode on the left, and then you will have the cathode on the right. So we need to figure out our cathode and anode. Okay, according to the answer given to you in your marking scheme, according to this, it seems that the anode for this is this electrode. Y is the anode and X is the cathode. The only reason I could find for this to be the case is that this actually has a minus sign over here. So maybe that's why this is considered to be the cathode. However, I couldn't find a valid justification to be okay with this particular answer. So according to your CBSE syllabus or according to your CBSE marking scheme, it says that this Y is the cathode and X is the anode. Okay, but according to a normal representation of a Daniell cell or an electrochemical cell, what over here you have is you have the anode on the right and the cathode on the left. Okay, now based on this, the answer actually has to be that X is the anode and Y is the cathode. Okay, and also definitely let me know if you have a valid reason as to why you think what's given in the CBSE textbook is right. I couldn't find anything, which is why I think both of them might be right. I don't know. I'm not sure. So definitely let me know. You can add it in the comments below. But basically, always remember when you have electrochemical cell X or for the representation, you're going to have anode and then you have the salt bridge and then you have the cathode. And that's how this has been represented as well. Okay, now the next question is, where is it? Name the carriers of current in the salt bridge. So the carriers of the current in the salt bridge. Actually, this particular concept has been discussed in chapter called redox reactions in class 11. So that's where I was able to find this. So basically you have the migration of ions through the salt bridge is how the electricity is going from one beaker to the next. So the carriers of current are going to be the ions. The last question is, write the reaction taking place at the anode. According to the CBSE, the marking scheme, Y is the anode. So Y gives rise to Y2 plus plus 2 electrons. In my opinion, I don't think that Y is the anode. So I'm just going to say X gives rise to X plus plus an electron. Oh, solid. I'm sorry. So again, if you have a valid reason as to why, I did try to look for galvanometers and try and figure out what it is from there, but I could not. Again, if you have any sort of idea, definitely let me know. I'll be more than happy to have an edit added to the channel for this. Okay, the next question is for visually challenged learners. You have magnesium Mg2 plus, Ag plus, and Ag. We need to identify the cathode and the anode. And I just told you that when you have a representation like this, you're going to have anode on the left and cathode on the right. So the anode is going to be magnesium, which is on the left, and cathode is the silver. And we need to write the overall reaction. So Mg plus 2Ag plus gives rise to Mg2 plus 2Ag. Obviously, you'll have to balance out the equation. I can just write that really quickly over here. So you have Mg giving rise to Mg2 plus 2 electrons. Ag plus gives rise to Ag. Ag plus an electron gives rise to. So you have to have 2, 2, and 2. And so you'll be getting Mg plus 2Ag plus gives rise to Mg2 plus 2Ag. And the two electrons can get cancelled. So that's why you have the this as the answer for this question. And this is from the chapter Electrochemistry. Question number 20. Complete the following reaction by writing the major and minor product in each case. So you can pick any two of this and then you can just write the answer. Now I'm just going to discuss all of them, obviously. So based on the look of this, it seems like all of these are from the chapter of haloalkanes and haloarenes. So the first one is reaction with KCN. This is a nucleophilic substitution reaction, and for reaction with KCN, you have the ability of formation of C attachment of the bond formed between the CH2 and C or NC. Both are possible, but for KCN, it's going to be the RCN, that is the cyanide, that is the major product. Okay, or nitrile, which is a major product. So the answer is going to be CH3, CH2, CN. This is the major product. The minor product will be CH3, CH2, NC. So that's going to be the minor product. The next question is, it's an alkene reacting with HBr. So this is related to the concept of Markov-Nikov's rule. According to Markov-Nikov's rule, the halide component bonds preferentially with the higher substituted carbon, whereas the hydrogen prefers the carbon which contains more hydrogens. So this makes, I'm going to just write the answer to this question over here. So the major product for this would be CH3, CH2, CH, CH3, Br, and the minor product is going to be CH3, CH2, which is bromobutane. So the minor product is going to be halide attached to the carbon with more number of hydrogens. Major product is going to be halogen attached to the carbon which has less number of hydrogens or hydrogen atoms. So this is under the concept of preparation of halogen or alkyl halides, and specifically through the process or using the alkenes. The last question for this is, you have this is reacting with alcoholic KOH. Now, alcoholic KOH implies that it's undergoing the process of elimination reaction. Elimination reactions of alkyl halides leads to the formation of alkenes. Now, when it undergoes elimination reactions, there are two possibilities, right? So when you have, let me write the structure to this question right here. Okay, so you have CH3, C, because you have CH, right? So CH, and this is bonded to two methyl groups, CH, and then you have CH. Oh, sorry. I am sorry. Okay. CH and then Cl, and then you have CH3. So this can undergo elimination reaction, right? So the Cl is going to get kicked out from this carbon, obviously. The question is, does it form a double bond with this one or this one? And this is based on the Seitz's rule. According to Seitz's rule, the major product is the alkene which has greater number of alkyl groups attached to it. So let's write down our products. Let's write down both our products first. So CH3, C, CH3, double bond, C, H, CH3. Okay, plus it gets kicked out from this carbon atom. So that's going to be CH3, C, CH3, okay. CH3, and then you have a CH and double bond CH2. So between these two, this is obviously the more substituted double bond. That is, you have more alkyl groups attached. So that's why this is going to be the major product and this is going to be the minor product. This is under the concept of elimination reactions. After we learn all about the SN1 and SN2 processes, the next reaction you learn about is elimination. So based on Seitz's rule, you are deciding which one is going to be the major and which one's going to be the minor product for this reaction. The last question under this section is the presence of, is question number 21. The presence of carbonyl group in glucose is confirmed by its reaction with hydroxylamine. Identify the type of carbonyl group present and its position. Give the chemical reaction to support your answer. So obviously this question is from the chapter biomolecules. Now, according to this is what I got. This is again directly from your textbook. I was able to obtain it from the structure of glucose. So glucose gets oxidized to 6-carbon carboxylic acid, gluconic acid on reaction with mild oxidizing agent like bromine water. This indicates that the carbonyl group which is present is a aldehydic group. So the carbonyl, so the answer given in your in the marking scheme is the carbonyl group present in glucose is aldehyde and the C1 and at the C1 atom. So glucose gets oxidized to 6-carbon carboxylic acid, gluconic acid with COH group at the C1 on reaction with the mild oxidizing agent like bromine water. This indicates that carbonyl group is present as an aldehydic group. And you can also possibly include the reaction as well if you'd like. And if you just mention the name, that's amazing. Also, if you found this video helpful, definitely let me know, and that you can let me know by dropping a comment or dropping a like. That definitely boosts my confidence and lets me know that you actually enjoyed the video. So in this video, we're going to specifically be talking about section C. This section contains 7 questions with an internal choice and 1 question. So they're all short answer type questions and they carry 3 marks each. So we're going to start with question number 22. Write down the reaction occurring on 2 inert electrodes when electrolysis of copper chloride is done. What will happen if a concentrated solution of copper sulfate is replaced with copper chloride? So from what the solution looks like in your in the marking scheme, it seems like all they care about is what has happened to the electrolysis or the product of electrolysis when you have copper chloride and the product of electrolysis of copper sulfate. The thing is, for copper chloride, whatever they've given over here is absolutely right. That's exactly what we expect. We expect to see cathode having a reduction taking place. The copper ion gets reduced, and anode, you'll have oxidation of chlorine, and then it leads to the release of chlorine gas. The issue I have with the answer over here, and for sure you can let me know if you think my thought process is incorrect, but I think the SO42 minus giving rise to or undergoing oxidation is incorrect. First of all, sulfate, for the sulfate ion, sulfur is in its maximum oxidation number in the sulfate ion. This means that it cannot further undergo oxidation that easily, right? So let's say, for example, here they've also said that we're talking about a concentrated solution. So even if there is a concentrated solution, it means that it's going to have some amount of, and again, this is what I understood. what I understood was that the solution is made of water and copper sulfate, right? So that means even then there is some amount of water, and the reaction in anode for this particular thing is going to be 2H2O gives rise to O2 plus 4H plus 4 electrons. And this is especially based on the fact that sulfate ion does not like undergoing oxidation. Okay, now if you find, if let's say we have a different solvent, I found online that copper sulfate can dissolve to an extent in methanol. Even when that happens, the methanol itself is going to undergo the oxidation reaction, leading to different byproducts even before the sulfate ion. Again, if you have an idea as to why this might be incorrect, definitely let me know. But according to me, in the anode, the reaction is going to be for the water molecule. Okay, now the next, and this was from the chapter electrolysis, electrochemistry. The second question under this is write an expression, and it's 2 marks, right? So you have, yeah. Write an expression for the molar conductivity of aluminium sulfate at infinite dilution according to Kohlsch's law. So according to this, you have the dissociation is given by V plus for cations, V minus, so you have lambda naught M equals to V plus lambda naught plus V minus. So essentially using this equation, we are able to get to this place. Now, obviously Al2SO4, so aluminium sulfate, I hope at this point you know how to do the crisscross method and get the formula. And basically you are having to add the number of atoms in the front, or in this case of sulfate, the number of ions. But basically you have to add that to include that in the equation itself. And obviously this is also from the chapter electrochemistry. It's under variation of conductivity and molar conductivity with concentration. Okay, now the next question, question number 23. Account for the following, and we have 3 give the reasons why, and each of them is 1 mark each. So the lowest oxidation transition metal is basic and the highest is acidic. So obviously, since the word transition metal has come up, we're going to assume safely that it's from the chapter D and F block. And by the way, this is actually a textbook exercise question, 8.25, the first part. This is the same question. So they've given you the exact same question that is in your textbook. Honestly, I wish I'd known a lot more things than I did. Than I do right now when I was in my 12th class. So basically the lowest oxidation of the transition metal is basic, and then when you have a higher, as the oxidation goes up, you have a more acidic nature. Now this is because in lower oxides there are some electrons which are in the valence shell, and these electrons don't like taking part in the formation of bonds, so they like to give those electrons away. They don't want it anymore, and that's why they act as a base. Now, for higher oxides, they don't have enough electrons in the electronic shell, and because of that, there's not enough for donation. They can't give it away as freely, and because of that, they act as acids. So that's related to the ability of donation of electrons in lower oxidation state versus higher oxidation state. And this is under the oxides and oxanions of metals. It actually gives you the example, but it never tells you why. I think they have assumed that because this is one of the questions that gets asked, that's asked in the textbook back questions, you should know. And I hope you do. The next question. Chromium is a hard metal while mercury is a liquid metal. We obviously know mercury is the only liquid metal, and the reason a chromium is a hard metal is because of something called as interatomic metallic bonding. So there is a metallic bonding in between the atoms, and this is mainly, okay, let me do this. Hang on. Okay, so this, first of all, let's look at the electronic configurations of chromium, which is CrAr, which is argon, 3d5, 4s1. Okay, now on the other hand, mercury is Ar again. Oh, sorry, different line. I'm so sorry. Oops. Just control Z this. Okay. xenon, 3D, oh, control Z again, 4F14, 5D10, 6s2. So difference between these two, one very important difference is the fact that this has unpaired electrons, this does not. So mercury does not have unpaired electrons, and because of that it does not form the interatomic metallic bonds. However, chromium has that, and because of the formation of interatomic metallic bonds, it is a hard metal, while mercury is a liquid metal, and that's what is the reason given over here as well. Or that is the reason given over here as well. I'm so sorry. Okay. Now the last question. The ionization energy of elements of the 3D series does not vary that much with increasing the atomic number. Now for all our, till now whenever we've talked about the periodic table, the one thing that has been consistent is the fact that when you have an increase in atomic number, the ionization energy also changes. But the ionization energy for the 3D series does not vary much. This is because when you have an increase in the electrons, what happens is we've understood the 4s and 3D orbitals are closer in energy. And because they're closer in energy, what happens is when you have increase in the number of electrons, basically the increase is going to be balanced because of the shielding effect. So the 3D orbitals, what they're going to do is they're going to make sure that the nuclear charge doesn't get as strongly or doesn't affect the 4s as strongly as it would. Okay, and because of that, you will have an issue in terms of the increase in nuclear charge is actually counterbalanced by the shielding effect. And because of this, the ionization enthalpy, you observe an irregular trend. Okay, I apologize. It's been a long day and I don't know if you've noticed, but yeah. Okay, question number 24. So as long as you mention the fact that the increase in effective nuclear charge is counterbalanced by the shielding effect, you should be good to go. Okay, and all of these were from the chapter DNF block elements. The last question was from ionization enthalpies. Okay, the next question we have over here. Give the chemical reaction involved when para-nitrotoluene undergoes ETARD reaction. Now, ETARD reaction is a named reaction, and you should be knowing all the named reactions by now. And I hope you do. If not, I do have a series where I have all the named reactions in one place. So definitely check that out. And each reaction has its own video. So you can, pick and choose whichever you want to learn. I would recommend learning everything just to be safe. But give the chemical reaction involved when para-nitrotoluene undergoes ETARD reaction. Now, this is one of the preparation methods of aldehydes from hydrocarbons, specifically by oxidation of methyl benzene. So you have here, you have we have toluene, but when you have nitrotoluene, the only thing different is going to be having a nitro group in the para position, which just means that you're going to have an NO2 group over here. Okay, that's going to be the same over here as well, but basically you're going to get, this is one of the preparation method of benzene using chromyl chloride, and that leads to this reaction being called as ETARD reaction. Okay, so that's the first one, and that's exactly what's been given here as well. The next question you have over here is, why does benzoic acid exist as a dimer in an aprotic solvent? Now, again, this is related to the chapter aldehydes, ketones, and carboxylic acids. It's specifically about the physical properties of carboxylic acids. So carboxylic acids like to stay in a dimer state in an aprotic solvent because of intermolecular hydrogen bonding. Intermolecular hydrogen bonding exists between two different molecules, and in this case, if you see, you have an intermolecular hydrogen bond between this O and the H, and then another H and O. Because of this, it likes to stay as a dimer, and it's enjoying that. So as long as you mention the fact that it undergoes intermolecular hydrogen bonding, you should be good to go. The next one is benzene on reaction with methyl chloride in the presence of anhydrous AlCl3 forms toluene. What is the expected outcome if benzene is replaced by benzoic acid? Give the reaction. Give the reason for your answer. Not the reaction, the reason. So basically, one of this is benzene on reaction with methyl chloride. If you remember, this is actually Friedel-Crafts reaction. However, Friedel-Crafts reaction, the carboxyl group does not, or let me, oh yeah, aromatic carboxylic acids undergo electrophilic substitution reaction in which the carboxylic group acts as a deactivating and meta-directing group. They do not undergo Friedel-Crafts reaction because of carboxyl group being ring deactivating, and the catalyst aluminium chloride bonds with the carboxyl group. Because of these two reasons, it does not undergo Friedel-Crafts reaction. So as long as you mention these two reasons, you should be fine. Okay, and I'm pretty sure Friedel-Crafts reaction is in the chapter haloalkanes and haloarenes. If I'm not wrong, it's one of the preparation methods of haloarenes. Again, you can for sure correct me. It's perfectly fine. Okay, question. So this particular question has an internal choice. So an organic compound X does not undergo aldol condensation. However, X with compound Y in the presence of a strong base reacts to give the compound 1,3-diphenyl-proptuene-1-one. First of all, the first thing that you realize over here is that it's not undergoing aldol condensation. Okay, you should know by this point, again, another named reaction. So an aldol condensation is between two carbonyl groups, right? So the product so we need to figure out what X and Y are. Okay, now the product that we have over here, 1,3-diphenyl-proptuene-1-one, is basically, let's draw the structure of that. And that's what I would recommend. If you are stuck in something, definitely just try and see if you can draw the structure of the final product. You might find something that you could use to answer the question. So you have CO, okay, CH, double bond CH, and another benzene. Okay, now here, so essentially you have X with compound Y is reacting in the presence of a strong base to react to give a compound this. So this is essentially the cross aldol condensation. Now if X is not undergoing aldol condensation, it means it does not have an alpha hydrogen. That is one very important thing we are learning from this. So X does not have the alpha hydrogen, whereas Y has the alpha hydrogen. Because of that, it's able to undergo cross aldol condensation. So by just drawing a straight line, so you have a breakage of this particular bond. So your products are going to be, and this like retrosynthesis product is going to be, you have benzene with CO, CH3, okay, and then you'll have benzene, CO, H. Okay, so it's obvious one of these doesn't have the alpha hydrogen, which is this guy, and this is going to be X and this is going to be Y. Interestingly, under the concept of cross-aldol condensation, this exact reaction is given in your textbooks. So you have benzaldehyde and acetophenone undergoing the cross-aldol condensation to give us this particular product. And so, we needed to identify X and Y, and that's exactly what we did. Chemical reaction involved, you're going to have to write this reaction, and chemical test to distinguish. So essentially we have to distinguish an aldehyde and a ketone. So the way we do that is by the tolerance test. So when we warm it in ammoniacal silver nitrate, so basically it's the silver, it causes the color of or it forms a mirror inside the test tube. Actually, it's pretty cool. I've done it. But basically, the tolerance reagent, benzaldehyde, will give us a product. However, the acetophenone does not react with tolerance reagent. And because of that, and that's how we are able to distinguish between the two. Question number 25. Give the structure of all the possible dipeptides formed when the following two amino acids form a peptide bond. So we have alanine and glycine. Both of these you basically under, oh wait, that's, that the previous question was, the second part of previous question was also based on aldehydes, ketones and carboxylic acids. So this question number 25, is obviously based on the chapter biomolecules. So we have something called as peptide linkages, which are formed by the loss of water, and the CONH is the peptide linkage. So you have two possibilities where you have the COOH from the glycine and NH2 from alanine and NH2 from glycine, or it could be the other way around where you have this, and that's how your the marking scheme has given us, where we have glycine and alanine, and then you have it the other way around where you have alanine and glycine, excuse me. Okay, so that's all. We just have to remove a water molecule and you should be able to easily write the reaction or write the formula or the structure of the final peptide bond. Okay, the next question. Keratin, insulin and myosin are few examples of proteins present in the human body. Identify which type of protein is keratin and insulin and differentiate between them based on their physical properties. Now this is based on the next topic under the structure of proteins. You have a classification of proteins into fibrous and globular proteins. So you have the example of fibrous protein is keratin, and the important thing is that they run parallel to each other and they're held together by hydrogen and disulfide bonds. Okay, so that's one structural difference. On the other hand, globular proteins, the example we have over here is insulin and albumin, but basically the structure, the chains of polypeptides, they're coiling around each other, which gives them a spherical shape. That's why you call them globular proteins. Obviously, they're further divided, but as long as you mention what kind of protein each of these questions are and how they are different, you should be good to go. And this is also from the chapter biomolecules. The next question we have over here is question number 26. Neeta was experimenting in the lab to study the chemical activity or chemical reactivity of alcohols. She carried out dehydration reaction of propanol at 140 Celsius to 180 Celsius. Different products were obtained at these two temperatures. Now we need to identify the major product at 140 and the mechanism. And we have to identify the major product at 180. Now, if you are really questioning if you know the answer to this question, what I would recommend is just switching from Celsius to Kelvin. So once you switch it to Kelvin, it's one of the preparation methods that we use for the preparation of ethers. Okay, now this is under the chapter alcohols, phenols and ethers. And by dehydration of alcohols, we are able to prepare ethers, but at different temperatures, you have different products. Okay, at a lower temperature, you have the formation of the ether, right? And this is formed by the SN2 reaction. Okay, so you would just have to mention that the diethyl ether is the product, and the mechanism that leads to the formation of diethyl ether is the nucleophilic or SN2 bimolecular reaction. Oh my god, nucleophilic bimolecular reaction. Okay, and if I said substitution, I apologize. It's nuclear bimolecular reaction. We need to mention that. And then identify the major product at 180 Celsius. In this case, because at a high temperature, it undergoes the process of elimination. So it undergoes E1 elimination actually. And so it leads to the formation of CH2. So you just need to mention what the product is, ethene and diethyl ether, and you should be perfect. All right, now the next question you have over here is various isomeric haloalkanes with the general formula C4H9Cl undergo hydrolysis reaction. Among them, compound A is the most reactive through SN1 mechanism. Identify A citing the reason for your choice. Write the mechanism for the reaction. So obviously it's from the chapter haloalkanes and haloarenes. And the moment you have, oh, which mechanism? Oh, SN1, why is it undergoing SN1? It's obviously nucleophilic substitution reactions, right? So based on the formula, it's obvious that the compound given to us is 2-bromo 2-methyl propane. That is because not just the formula, also the fact that it undergoes SN1 reactions. SN1 reactions are predominantly we know that tertiary alkyl halides prefer to undergo SN1 reactions, and I'm sure you know why and what's the preference, all of that. But if you do not, definitely check out the video I have related to nucleophilic substitution reaction. I talk about it for an hour, so I hope that helps. And this is from I did mention that it was from haloalkanes and haloarenes. So basically you just have to mention the mechanism. And the reason we have this undergoing SN1 reaction is because the carbocation that is formed is stable, and this is because of a particular effect because of the alkyl groups. And definitely comment what the effect is below. You do remember, like inductive effect, mesometic, all of those. One of those effects is causing this. Definitely let me know in the comments below. So that's all. You just need to mention the mechanism and you should be fine. The last question under section C. So we've been given a reaction over here. Okay, and we've also been given the equilibrium constant. Now, the moment I saw this, I was like, hang on, you guys don't have equilibrium in class 12. But this is related to the chapter electrochemistry because we need to calculate the standard EMF of the cell. Now, we've also been very conveniently given the value of log. So that obviously means we need the value of log in our equations, right? So basically, according to the relationship between E naught cell and the value of Kc, the equilibrium constant, this is the final relationship that we get, and this is from your textbooks. However, at 25 Celsius, you have at 298 Kelvin, you have E naught cell is 0.0591 log Kc by m. Now, one very important thing I wanted to point out over here was that because the number of electrons are not the same in both cases, we would have had to multiply it with this into 3 and this into 6. Okay, and that's how, this into 2. So your final balanced equation is going to be 3SN4 and then 6 electrons and then 3SN2, and then this is going to be 2, 2, and this is going to be 6. Okay, so your final equation is 3SN4 plus 2Al gives rise to 3SN2 plus 2Al3 plus. But the more important thing is the fact that there are 6 electrons. So the value of N over here is going to be 6. Okay, so you just have to substitute it and you'll have to solve the equations to get to the value of E naught cell. And notice they started with 0.0591 and then the next equation you can just ignore the 1 and just do 0.059 and you should be fine. Okay, so you're getting the value of the E naught cell, and we know, and the next question is what will be the E naught cell if the half cell if E naught of half cell is so and so. So we've been given the value of one of them. We just need to figure out the value of E naught cell of the other. We're using this particular equation where E naught equals to E naught R minus E naught left, or you could also think about it as E naught cathode minus E naught anode. So you have Sn minus Al, 3 plus Al. Okay. So section D, so usually you have a case-based questions in this section, and it carries 4 marks of 2 plus 1 plus 1 each. We need to read the paragraph carefully. This is the 6th time I'm trying to start recording this video, and I realized that reading through the whole thing is not you can read through the whole thing. You should definitely read through the whole thing, but I'm going to point out some very important points from this given paragraph. So basically this paragraph talks about how you can't predict a reaction from the overall stoichiometry of that particular reaction. It's a lot more complex than we think it is. Okay, so they took an example of specifically hydrogen gas, reaction of hydrogen gas with bromine to give us hydrogen bromide. And according to them, the concentration, the rate of the reaction was found to be proportional to the concentration of H2 and its square root of concentration of Br2. So this is the important points that and basically the currently accepted mechanism is more complicated, because you would think, if you think about it, the bromine molecule has to dissociate and to form atoms, and then it undergoes a chemical reaction to form hydrogen bromide. So it's a little more complicated. That's what they're basically saying. So from here, we obviously know that this is from the chapter Chemical Kinetics. So first question over here is predict the expression for the rate of the reaction and the order of the following. So we need to basically calculate or write the expression of the rate of the reaction. Now in your textbooks, right, I decided I'm just going to bring out the whole textbook to you guys for this video, because the questions are very specific, and also I don't know, I just felt like it's easier to have it here. Okay, so from the rate equation, you know, rate is equal to K into A to the power X into P to the power concentration of B to the power Y. From here, they've already told us that the rate is proportional to the concentration of H2 and square root of concentration of Br2. And because of that, you will have, the rate would be equal to K into concentration of H2 into concentration of Br2 to the power 1 by 2, because it is proportional to square root of concentration of Br2, and so we have to incorporate that, so it is half. The next question we have over here is the order of the reaction. So the order of the reaction is essentially going to be X plus Y. That's all it is, right? I wonder if it's the, yes. So according to this is the rate of the reaction equation, and the order of the equation is going to be X plus Y equals to N. So over here you will have X, which is 1 plus 1 by 2, which is equal to 3 by 2. That is the value of N, right? That's the order of the reaction. The third question is the units of the rate of the above reaction. So essentially what we are going to do is we are going to use this particular equation. Okay, according to this, you have concentration by time. So into 1 divided by concentration to the power N. Okay, so you're going to have moles. So the units are going to be moles per liter per second, because concentration moles per liter per second is for by time, into 1 divided by moles per liter, because concentration, right? And this to the power 3 by 2. When you simplify all of this, that's where you get, this. That's how they've gotten this equation, and that's how you get the value of, or the units, which is mole to the power minus 1 by 2, liters to the power 1 by 2, and per second. Okay, so essentially we just use this equation to substitute and calculate the unit of K. Okay, so obviously this particular question was related to the molecularity, order, and the rate of the reaction. Okay, I hope that made sense. Now the second question, how will the rate of the reaction be affected if the concentration of Br2 is tripled? Now essentially what we are trying to do is we are seeing what will happen if we triple the concentration. I wonder if they've calculated this. So what they've done over here is basically rate dash is going to be 3 times the concentration of Br2. Now basically what we come to is rate dash is a root over 3 rate, which basically means that the rate is going to be root over 3, square root of 3 times of the rate of the original reaction. So since the rate is proportional to the concentration of H2, when concentration of the bromine is triple, the rate of the reaction is also, or Br2, the concentration is also going to increase, or the rate is also going to go up. Okay, now how will, or what change is the concentration of H2 so first of all over here, if you notice, rate of the reaction is directly proportional to hydrogen concentration. Because of that, the rate of the reaction will also increase or will also be tripled when the concentration of hydrogen is tripled. Okay, so essentially these two are quite related to each other. We're talking about how the concentration, when it's tripled, how will it affect the rate of the reaction. For Br2, it's root over 3 because of the square root that exists for bromine concentration, whereas this is a directly proportional, so it'll just increase by 3 times. Okay, the next question. Suppose the reaction between A and B was experimentally found to be first order with respect to both A and B. So the rate of the reaction or reaction equation is going to be rate equals to K of concentration of A into concentration of B. Which of these two mechanisms is consistent with the experimental finding? Why? Now we know from, I know that this is something you obviously know, that the rate of the reaction depends upon the slow step. So whichever slow step has both A and B, that slow step is what is going to be the mechanism. In this case, A gives rise to C plus D is a slow step. However, we know that it is the rate of the reaction is dependent on both A and B. So in this case, the rate would have just been dependent on A. So mechanism 1 is going to be wrong. On the other hand, mechanism 2 has both A and B in it, and we know that the rate of the reaction is dependent on the slow step. And so, or it's also called as the rate determining step. The rate determining step is always the slow step. So mechanism 2 is going to be the right answer. And this is also under the molecularity of the reaction, where they talk about the rate determining step. Okay, now question number 30. Now here, they've talked about amines. So amines is obviously from the chapter amines. Amines are basic in nature. So they've given us the pKb value is the measure of basic strength of an amine. Lower the value of pKb, more basic is the amine. The effect of substituent of basic strength is determined using titration. Substituent X is replaced in piperidine and propylamine. So basically, they've given us an experimental data which gives us basically the substituent, the electronegativity of that substituent, substituted piperidine, pKa, substituted propylamine, pKa. So they've given us the values of pKa. Okay, now study the above data and we need to answer the following questions. So plot a graph between electronegativity of the substituent versus pKb value of the corresponding substituted propylamine. So essentially we need to plot a graph between electronegativity of X and the pKb. Okay, now we also know that pKa plus pKb is 14. So the thing is, over here, the moment I read this question, I was like, oh, we've not been given enough information. No, it's all right here. So remember to calmly read the question. Unlike me who jumps to conclusions. It's okay. So basically what you'll be doing is you'll be calculating the value of pKa by subtracting 14 from this value. Okay, because pKb is 14 minus pKa. So we're just going to subtract 14 minus 10.67, 10.08, 9.45, 9.28, and we are going to get the corresponding pKb values. Okay, because they themselves have given us this. Okay, so based on that, we are going to get a graph like this. Essentially, what we've just done is plotted a graph between the electronegativities and the value of pKb. That's it. Okay, now, is there a relation between electronegativity and the basic strength? We've noticed that when you have a highly when pKb increases with the increase in electronegativity. So basic strength decreases when the electronegativity increases. Now logically this also makes sense because that will mean that these electronegative ones will decrease the basic strength of our molecule. Okay, so that's it. So more electronegative substituent weakens the basic nature, because when it pulls more electrons towards it, it will make it difficult for the compound to act as a base. Okay, so this is a very straightforward question. All you have to do is calculate the value of pKb and plot a graph between this and this. I believe in you. You got this. The electronegativity of substituent is 3.7. What is the expected pKa value of compound so and so? So we need to essentially calculate the pKa value. Actually, we don't. They've given us these options and we need to figure out which one's the right answer. Now, the electronegativity of this substituent is also given to us. Now, basically we spoke about one very important thing. When the electronegativity increases, the pKa value is also going to decrease, right? So this obviously means that the value of this particular thing should be less than 9.28. Because of that, the only option that fits that is 9.1. Okay, so this is just a general trend relationship that we are observing, and from there we are able to figure out the value is 9.1. The other options are obviously about 9.28. The second question, the pKa value of the substituted piperidine formed with substituent X is found to be 8.28. What is the expected electronegativity of X? Now we are talking about piperidine. Okay, pKa value is going to be 8.28. Now 8.28 as in it's in between 8.36 and 7.94. That's the value of pKa. It's in between these two, and it's actually closer to 8.36. Okay, so this implies that the answer we are supposed to mark off is going to be closer to 3.44 and in between 3.44 and 3.6. So out of all of these options, 3.4, 3.8 and 3.1, none of these are within the criteria that we wanted, and because of that because it has to be above 3.44. 3.4 is obviously below, so the answer is going to be 3.5. Okay, I hope that makes it took me a second to figure these relationships out, but it made sense in the end. What is the most suitable pKa value of the substituted propylamine formed with the substituent X with electronegativity 3.0? So we're talking about propylamine with electronegativity with a substituent of electronegativity 3.0. Again, it's the same thing over here. You have a relationship between the electronegativity and pKa value. So the 3.0 is in between 2.55 and 3.12, again closer to 3.12, right? So the value has to be in between 10.6. The pKa value has to be between 10.67 and 10.08. So amongst the options that are given, 10.67, 10.08, these are our upper and lower limits based on this question. So the obvious answer is 10.15. Okay, so all of these are just looking at the information given to you and you're just figuring it out. You got this. The next question is for visually challenged learners. How does the electronegativity of the substituent affect the pKb value? So essentially what they're doing over here is they're asking you to basically tabulate the graph and just give them the values of pKb. So that's what is given in this solution as well. So you just have to write the value of pKb or calculate the value of pKb. So that's instead of the graph. And then you're just going to explain that when you have an increase in electronegativity, basic strength will also decrease because of the increase in electronegativity of the substituent. And then you have question B, C, and this question. All of this are the same for both cases. You're just figuring out the trend and trying to mark off which option suits the best. Okay, now that's it for section D. Section E. The following questions are long answer type. They carry 5 marks each. All questions have an internal choice. So I will bring out my whiteboard again. Hang on, let me actually. Okay, so, oh, I don't want that. Oh, I don't want that either. Okay, this is fine. So, a purple color compound A, which is a strong oxidizing agent and is used for bleaching of wool, cotton, silk, and other textile fibers, was added to each of these 3 test tubes along with H2SO4. It was followed by heating. So, this obviously is from the chapter. I mean, it is a purple compound A, so it's obviously going, and it talks about reactions with PBS, oxalic acid, and potassium iodide. So this is obviously from the chapter. And he guesses D and F block elements. We're talking specifically about potassium permanganate. right? So because that's the purple compound, and in under potassium permanganate you have the reactions in acidic solutions. So we need to figure out which of the above test tubes will by have violet vapors will be formed. So when potassium permanganate reacts with reacts with potassium iodide, it leads to the formation of iodine vapors, which is violet in color. So this implies that this is option, like it's test tube C. The second question, the bubbles of gas evolved will extinguish a burning matchstick. So this is the burning matchstick getting extinguished is a characteristic example of the carbon dioxide gas. So oxalic acid is the reaction with which it forms carbon dioxide. And they are asking us to write the chemical reaction. So you just need to mention these, and that's what is given in your solutions as well. But these are actually given in your textbooks too. Now the next question, a metal ion Mn plus of the first transition series having D5 configuration combines with 3 didentate ligands. Assuming delta 0 is less than P, we need to draw the crystal field level diagram. So basically we know that the free metal atom, and then it has 5 its ion has 5 electrons in the D3D D5 configuration. So you have 5 electrons. Now it splits up into Eg and T2G. Basically, based on the strength of your ligand, it determines if the if the electrons will get paired up in the lower level, or it will move on to this Eg level. So here they've told us that delta is less than P. So this implies that the fourth electron will enter one of the Eg orbitals. So that's the reason it is entering this orbital, and so it'll enter this and then this, because of this the fact that the delta is less than P. Now this is based on obviously the chapter coordination compounds, and it specifically is dealing with the concept of crystal field theory. We need to, what is the hybridization of Mn plus in this complex and why? Now we obviously have 3 didentate ligands, so that implies there are 6 bonds. So if or coordination number is 6. I'm so sorry, I've been doing a lot of organic chemistry. So the coordination number is going to be 6. So you have 2 options. You have sp3d2 or d2sp3 for the octahedral complex, right? So basically the strength of the ligand determines if this is going to be d2sp3 or sp3d2. So d2sp3, as in what will happen is it will force it to pair up. Okay, so if the ligand is a strong field ligand, what it will do is it will force the things to pair up, and then it will lead to the formation of D2sp3. However, ours is a weak field ligand, and because of that, it will just chill and it will just let it bond on the sp3d2 hybridization. So it will lead to the sp3d2 hybridization, and so the answer to this question is going to be sp3d2 because of the fact that it's a weak field ligand. Okay, now the next question, name the type of isomerism. So under the concepts of isomerism for coordination compounds, you have that the optical isomerism is common for octahedral complexes involving didentate ligands. So because of that, this will show optical isomerism. Okay, now the next question. So this question was basically related to the valence bond theory and crystal field theory of coordination compounds. The next question, that's your option, is also related to these concepts. So you have, based on valence bond theory, we need to identify A, B, C, D, E, and F. So first question over here you have is we need to find the central metal ion. So the central metal ion in this case, what is it going to be? Now we know, I'm going to zoom that in a little bit. Hang on. Oopsie. Okay. So you have COF4 2 minus. That's the okay, so you have, ooh, okay, why is this? Okay, So COF. I'm going to 4, 2, minus. So now we need the central metal ion. We need to calculate the oxidation number. So X plus 4 into minus 1, because that's the charge by fluorine ligand, and this is equal to minus 2. So we just have to solve for X. So that's going to give us X equals to 2, because 4, it goes to this side and then it becomes plus, and then you are left with X is equal to 2. So the ion is going to be CO2 plus. Okay, that's the first one. The next question over here you have is the number of unpaired electrons. So the number of unpaired electrons for this, we've been given that it is 3d7, right? So 3d7 as in 3d7. So 1, actually I should just so 3d7, 1, 2, 3, 4, 5, then 6, 7. So you have how many unpaired electrons? If you said 3, you are correct. So you have 3 unpaired electrons. So the answer to B is going to be 3, and that's what is given over here as well. Let me scroll that down. So we have that as well. So the next question is related to this particular complex. So we need to figure out the hybridization of the metal ion. Over here you have C2O4 twice, which is C2O4 is as such a bidentate ligand. So it's going to form 2 bonds. I mean 2 bonds with the central metal atom. So you have the total of 6, right? So that's going to be an octahedral complex, which is also given over here, I guess. So here your this is 3d3. So because you already have 3d3, it's just going to basically use the D2 sp3 configuration, because it already has these 2 spots free. So it's going to undergo D2 sp3 hybridization. No, I guess. Oh my goodness. Just gonna say D2 sp3. Okay. The next question is related to the magnetic behavior. Now, since you have these unpaired electrons, it's going to be paramagnetic. Okay. Now, the last question is related to a nickel complex. Now, we need to figure out the hybridization. Over here, it has 4 ligands attached to it. And so, from this, we know that it can either be tetrahedral or it can be square planar. Tetrahedral if it's an sp3 hybridization, dsp2, and then it's a square planar. Now from this, we can see that 3d3 and 3d8, 4s2, that's the configuration of central metal ion. So it's 3d8, 4s2. Okay, so this obviously means that it's not going, it's basically the cobalt is going to push all of your electrons, these 2 electrons, into 3D shell. So it's going to be 3d10 for your metal atom, and it's basically going to be filled up, and then it'll have the sp3 available for the metal ligand bonds and so coordinate bonds, and so the hybridization is going to be sp3, which is tetrahedral. Okay, so the hybridization is sp3 and the geometry is going to be tetrahedral. I hope that made sense. All right. The next question. Write the ionic equations for the reactions of acidified potassium dichromate with H2S and FeSO4. So basically this is the reaction given to you in your textbooks, but remember it's an ionic reaction, so you have to make sure it's balanced. So they've only talked about the reaction with iron. You will have to balance it and get this to write the reaction with H2S. Okay, the next question number 32. Give the reactions for the following. I love organic chemistry, I'm not gonna lie. The reaction of ethanol with acetyl chloride is carried out in the presence of pyridine. So this is from the chapter alcohols, phenols, and ethers. So this is one of the reactions of ethanol with acetyl chloride, and it's basically acidification reaction. So essentially what's happening is we need some amount of pyridine because because it's right here. It's carried out in the presence of pyridine, so it is neutralizing the HCl which is formed during the reaction. So because it is neutralizing the HCl, the reaction will keep moving in the forward direction. To make sure that the equilibrium is constantly on the forward direction, we need the addition of pyridine, and that is what is given here as well. Next question, cresols are less acidic than phenols. So cresols are essentially compounds where phenols are substituted with a methyl group. It could be ortho, meta, or para. But basically, the acidity of phenols depends upon the ability of the formation of phenoxide ion. Now, when you have an alkyl group which is electron releasing in nature, what happens is the phenoxide ion will basically this will in turn not favor the formation of the phenoxide ion, and because of this, cresols are less acidic than phenol. Okay, and this is under the concept of acidity of phenols. The next question is, Williamson's process is used for the preparation of ethers to form ethers from alkyl halides. Identify the alkyl bromide and sodium alkoxide used for the preparation of 2-ethoxy 3-methyl pentane. Now, the Williamson synthesis is the preparation of ethers, and this is the reaction. Basically, it will prefer the primary alkyl halide. Now, what we're going to do is we're going to write the structure of the product that is formed. So first start with writing the structure of the product form. For us to do that, we know that the bigger chain is going to be consisting of 5 carbon molecules. So this you have 5, and in the second position you have the OCH3 group, because CH2CH3, and then you have the methyl group in the third position. Now we're just going to fill in the hydrogen atoms. So 1, 2, 3, and this will be 4, and then 1, 2, 3, 4, H2. So this is the ether that is formed. So since it prefers to use primary alkyl halides, so this is going to be CH2 CH3 Br. Okay, so this is going to be the primary alkyl halide. The next one is just going to be this with ONA. So CH3, CH, CH, CH3, CH2, CH3. 1, 2, 3, 4, 5. And then you have ONA. So these two are going to react to form the ether. Now I did notice that this particular thing given is slightly different than what we have over here. If you have a valid reason as to why this is the right answer, definitely let me know. But basically what I had just done was you have the R-ONA, and I know that the R- group is this whole group, and because of that I just said this. So if you have a valid reason, definitely let me know. The next question you have over here is we need to convert toluene to 3-nitrobenzoic acid. So for us to do that, this is from the chapter aldehydes, ketones, and carboxylic acids. So first of all, we're going to form alkyl benzene or form aromatic carboxylic acid from alkyl benzene. So toluene undergoes this particular reaction to give us benzoic acid, and then the benzoic acid that is formed undergoes a simple substitution reaction or ring substitution reaction to give us metanitrobenzoic acid. So this is an example of a ring substitution reaction. And I also noticed that this was a question, or there was a question related to this in your textbooks. The next question, benzene to metanitroacetophenone. So basically we want this product similar to this COCH3 because acetophenone. For us to get from benzene to this, first of all, we want benzene to get converted to nitrobenzene by reaction with HNO3 and H2SO4, and this will in turn this on reaction with AlCl3 and anhydrous AlCl3 is basically Friedel-Crafts acylation reaction, and we're just using that to form metanitroacetophenone. Okay. The next question is the optional one, or like it's this or this. Out of formic acid and acetic acid, which one will give the Hell-Wohlad-Zelinsky reaction or HVZ reaction? Give a suitable reaction in support of your answer and write the chemical reaction involved. So Hell-Wohlad-Zelinsky reaction involves the alpha hydrogen of the acid. So this gives us alpha halocarboxylic acids. Okay, so basically the primary requirement for a particular molecule to undergo HVZ reaction is the fact that it needs to have an alpha hydrogen in between so let me just write that. We have HCOOH, which is formic acid, and CH3COOH. Formic acid obviously does not have an alpha hydrogen, acetic acid does, and because of that, acetic acid will undergo Hell-Wohlad-Zelinsky reaction. And remember to learn all the named reactions. I do have a playlist which covers each and every one of them, so definitely check that out. And this obviously was from the chapter aldehydes, ketones, and carboxylic acids. The question B, alcohols are acidic but they are weaker acids than water. Arrange various isomers of butanol in increasing order of acidic nature. Give the reason for the same. So first of all, what you need to do for this is you're going to have to write down the different I wonder if they are, no, the different isomers of the butanol. So you have CH3, CH2, CH2, CH2OH. This is one. You also have CH3, CH2, CH3, and then this will be OH. And then you can also decrease one carbon atom. So CH3, CH3, OH, and then the last one is going to just have this OH over here. So you are left with CH3, CH, CH3, CH2OH. So we're asked to order the acidity of the alcohols. So the acidic character is due to the polar nature. So when you have more electron releasing groups, what will happen is this will lead to a decrease in the difference in polarity between the oxygen and the hydrogen. So the most acidic is going to be primary, next is going to be secondary, tertiary is going to be the third. So because of that, you're going to have this as the most acidic, just a straight chain one. This is going to be more acidic than this, than this, than this, because this carbon is a tertiary carbon atom. This is secondary. No, this is secondary. This and this is primary. So the order is going to be 2-methylpropan 2-ol, 2-methylpropanol, butane 2-ol, and butane 1-ol. Okay, so this is based on the ability of or the number of alkyl groups that are attached to it. The next question is, an organic compound A with Grignard reagent is used to obtain 2-methylbutane 2-all. So basically, this is a reaction of production of alcohol from Grignard's reagent, and you have the reaction given as such in your textbooks for formation of a, notice that this is actually a tertiary alcohol, and for tertiary alcohols you need a ketone. So this is the reaction that's given in your solutions. Basically, you have butanone reacting with methyl magnesium bromide to form the product that we require in the end. Okay, so with that, we're done with question number 32. And this last one was based on the chapter Alcohols, Phenols, Ethers. We specifically about preparation of alcohols. Last question of this question paper. Great, right? So question 33. An experiment was carried out in the laboratory to study the depression of freezing point. 1 molar aqueous solution of AlNO3 taken thrice and 1 molar aqueous solution of glucose were taken. We need to identify 1 and 2 and give a valid answer. So this is based on the Van 't Hoff factor. So basically, the ability of production of the ions for AlNO3 is higher than that of the glucose. Glucose is not an ionic molecule, so when it dissolves in water, it's not going to lead to the formation of ions. Okay, so because of that, the value of I for glucose is going to be 1. For the AlNO3 is going to be 3 because of the basically you have the value of the value of I is 3. So because of more number of the or the higher value of the Van 't Hoff factor, there is going to be a higher depression in a freezing point. This is also because, notice, when you have the Van 't Hoff equation, you have delta TF is equal to KFM. So basically, delta TF is, if you have this, it's directly proportional to the value of I. So when you have a higher value of I, this in turn means that the depression of freezing point is much higher, or the temperature itself is lower. So solution 2 is going to be the AlNO3 taken thrice, and solution 1 is going to be the glucose. And again, if you think about it, glucose is not going to form ions, so you could also just say that because of the inability of glucose to form ions, it's the value of I for glucose is going to be equal to 1 because it just dissolves, right? So obviously this is ionic, so it is going to form more of that, and because of this difference, AlNO3 is going to be solution 2 and solution 1 is going to be the glucose. Now, the ones for visually challenged learners, which of the two solutions? So they've just given you the same question. All they've done is not given you the graph. They've just asked which of them will show a greater depression in freezing point, and all you have to do is mention the exact same reason for this question as well. Okay, just that the Van 't Hoff factor is different, right? Question B. The osmotic pressure of a solution of cane sugar was found to be 2.46 atmosphere at 300 Kelvin. If the solution was diluted 5 times, calculate the osmotic pressure at the same temperature. Now the osmotic pressure is given over here. So you have pi equals to CRT, or N by V into R into T. First of all, you know that the temperature and the value of R, both of these are going to be constant. And because the volume is also staying the same, the value of the volume is changing, but there is no addition of the solute to the solution. So because of that, the value of N2 is also going to be constant. So basically, you're just using pi 1 by pi 2 equals to N by V1 by N by V2. N and N can get cancelled, and V is equal by 5V because it is 5 times the volume. Now notice these people, they've used 2.64 and not 2.46. So the question given to you is related to 2.46. So the final answer is going to be pi 2, that is the final osmotic pressure, is going to be equal to 0.492 atmosphere. this is the final answer. If you're using the value of 2.46 atmosphere, they've flipped and they've used 2.64. Okay, now how can osmotic pressure of a given cane sugar solution be decreased without changing its volume? So essentially what we're wanting to do is we want to change the osmotic pressure, but we don't want to change the volume. So the only other thing that you can potentially, if volume is going to stay constant, then obviously the value of N, that is number of moles, is also going to be constant. So the only thing you can do is change the temperature. So the osmotic pressure is directly proportional to temperature, so it can be decreased when you decrease the temperature. Okay, the next question. While giving intravenous injection to patients, the doctors take utmost care of concentration of the solution used. Why is it necessary to check the concentration of the solution? So this is again related to the concept of osmotic pressure, and this particular example is actually given in your textbooks. So basically we don't want the concentration to be that different than that of the blood cells. So because this is because of, if it is more concentrated, it'll lead to shrinking. If it's more dilute, it'll lead to it'll start flowing out. And then because of that, or when its concentration is less, the concentration will lead to swelling. So all of these are not really good things, and all of this is also explained right here. Okay, and the next question. Okay, this honestly, it took me so long to solve this one. So a solution of phenol was obtained by dissolving 2 into 10 to the power minus 2 kilograms of phenol in 1 kilogram of benzene. Experimentally, it was found to be 73% associated. Calculate the depression and freezing point that is recorded. So basically, this is sort of related to the last example question given in your textbook. Okay, this is the closest I could find. Basically, what we need to do is we need to first figure out the value of value of I. For us to find out the value of I, we are going to use the relationship between alpha and I. Okay, so alpha is equal to 1 minus I divided by n minus, or 1 minus n. Okay, so this particular equation, when I try to figure out this equation on my own, I actually got alpha alpha is equal to I minus 1 divided by n minus 1. So essentially all you're going to do is try and calculate the value of I using 0.73. You know that 0.5 minus 1 is going to give us minus 0.5. This is somewhat related to what you learned in the chapter equilibrium. I know that's last year's stuff, but basically we're just using the final initial and the final concentration. We're comparing those two, and we're able to get to an equation where we're relating the value of alpha to the Van 't Hoff factor. And so we're calculating the value of I. Okay, and then we just are using this equation, which is also given in your textbook right here. No, over here. All you have to do is then just substitute all the given values in this equation, and the value for Kf for benzene is 5.12 kilograms per mole. I think it would be a good idea to just have a basic idea of the values of these, because this has not been given in this question over here. So all we're doing is substituting it and then figuring out the value of delta TF. With that, we're done with the sample question paper 2024-2025. Definitely let me know if you have any questions, if you found this helpful, and if you have a suggestion for a sample question paper or a previous year's paper, definitely let me know about that as well. Okay, bye.